year put together 25 questions. Definitely you can expect 13 questions from second year. Only dozen questions are from first year. If there are dozen questions, there are 14 chapters in 11th class. In these 14 chapters, one question definitely they ask from environmental chemistry. That is the easiest and the simplest. So from this chapter, you can expect one question, maximum two. Okay, sir? Hello?
Yes, sir.
Yes.
Based on this, you can decide if you want, you can leave one or two chapters, which will not fall. At the end in IITG in chemistry, you are supposed to get a score of at least 92. But there will be people who got 100 out of 100 because the questions are down to earth. They are very simple. If you have done NCERT exemplar thoroughly, you will be able to answer each and every question. If you study too much and unnecessary things, you will be in trouble. The problem is if you study too much unnecessary, what is necessary you can miss. You should almost buy out the textbook without any compromise.
Yes.
Okay. That is clarity. Now, these are the 10 model questions. Now, on each model, I speak one question. Each model for a practice. Look at these IUPAC names. What is the IUPAC name of isobutyl chloride? A very simple question. Or what is the IUPAC name of DDT? Can you name these compounds? If you look at MS Chauhan, he will ask you what is the IUPAC name of camphor? What is the IUPAC name of vitamin C? All these things they will ask in that book. Because
Why like that?
simply,
Why does vitamin C is not there in syllabus, right?
okay, sir, you are supposed to know what is the vitamin C, ascorbic acid. It is there in 9th class, but structure is not there. Simply
Yes.
they give practice. If you see MS Chauhan, you can see these questions. You understand? So there is nothing wrong if you know what is vitamin C. There is nothing wrong if you know what is camphor. But I don't know whether it is really required for IITG mains because they may not ask questions from this. Okay. So I am not insulting MS Chauhan. It's a wonderful book. Okay. Now, what is the IUPAC name of isobutyl chloride? Sir, butyl, this compound which has 4 carbons is called but. If I put Cl on first carbon, it's called chlorobutane, CH2Cl. Simply it is N-butyl chloride is common name. IUPAC name is 1-chlorobutane. Next, you have another possible compound called 2-chlorobutane. Notice this 2-chlorobutane is commonly known as secondary butyl chloride. It is called secondary because Cl is linked to a secondary carbon. Okay, sir? If you say secondary butyl chloride, there is no confusion. It is IUPAC name is 2-chlorobutane. Again, IUPAC names have no confusion. If you look at secondary butyl chloride, okay, again there is no confusion in this. No confusion. You look at this. What is the common name of this compound? Isobutyl chloride. This isobutyl chloride has IUPAC name 2-methyl-1-chloropropane. What is the IUPAC name, sir?
2-methyl-1-chloropropane.
Commonly known as isobutyl chloride. And now if you write like this, it is called a tertiary butyl chloride. Whereas IUPAC calls it as 2-chloro, 2-methyl propane. Are we very clear, sir? Hello? Hello?
Yes, sir.
Sir, now you see, this name, secondary pentyl chloride. This name is very ambiguous, you know that? Why it is ambiguous? If you are looking at pentane, how many secondary carbons it has, sir? Hello?
3.
It has 1, 2, 3 secondary carbons. If I put here Cl, it is called 2-chloropentane. There is a secondary pentyl chloride. If I put Cl here, that is also secondary pentyl chloride, but that is 3-chloropentane. So if I use the term secondary pentyl chloride, it is confusing. It is ambiguous. You understand? Hello?
Yes, sir.
Yes, sir.
If the name indicates only one unique compound without any sense of doubt, then this is called as non-ambiguous name. But if the name suggests two different compounds, then the name is said to be ambiguous. Are we very clear?
Yes, sir.
Very good. Now, what is camphor?
So how do we name the cyclic compound?
This is the camphor. Should I write again? I use
So now
black
how do
color.
we name cyclic compound like bicyclo like that?
Let us see that. But actually that is not required because it is not specified in NCRT. But anyway, you asked me, I am telling. Sir, if you carefully look at it, this is a methyl group. This is a methyl group. This is a methyl group. Can you see that clearly?
Yes, sir.
What functional group it has, sir?
Keto
Ox.
group.
It is a ketone. Now, if you want to name this type of compound which has two rings, you will be counting from bridgehead. Start number 1. You continue the numbers on the side where the number of carbons are more or where there are functional groups. So, 4 carbons, 5, 6. It is over now. So this is a compound having 2 rings and 7 carbons in the ring. Hence it is called 1,7,7 trimethyl. Can you see it, sir? Can you see 1,7,7 trimethyl?
Yes, sir.
Bicyclo. This side of the ring there are 2 carbons. This side 2 carbons. This side only 1. Maximum carbons it has is 7. So it is 1,7,7 trimethyl bicyclo 2,2,1 heptane. Yes, sir. What is heptanone? 2.
Sir, why are we writing bicyclo?
Because it has 2 rings. It is 1 ring and it is another ring. Compound which has 2 rings must be said bicyclo. It is 2 to 1 because one side there are 2 carbons, another side also 2 carbons, one side 1. So it is 1,7,7 trimethyl bicyclo 2,2,1 heptanone 2 is known as camphor. Are we clean about its name, sir? Hello?
Yes.
Try to
Yes, sir.
name this compound. Can you name this compound? Try to name this compound.
So phenyl 2,2, bicyclo 2,2.
Count like this: 1, 2, 3, 4, 5, 6, 7. So total 7 carbons will accept on 2 whole. Hepton 2 whole. Bicyclo 2, 2, 1. I'll write again. Bicyclo 2, 2, 1. Yes, sir. Is that
So where is alcohol
it?
group?
This.
Okay, that is alcohol group.
Can you name this compound, son? I'll write again. Can you name this compound?
So butane bicyclo 1,100.
Butane bicycle 1,1 is wrong. If you look at this, bicyclo 1,
1 propane.
0,
Butane.
Yes.
Any difficulty?
No,
So
sir.
how do we know
Understood,
when
sir.
to put bicyclo first or the compound name first?
You can see clearly it has 2 rings. This one ring. If you can see 2 rings in a compound, you should call it as bicyclo. You can
No,
see
sir,
2
like
rings.
when how do we know if you want to put butane bicyclo or bicyclo butane?
Sir, if it has 4 carbons, it is but, sir.
No, not like
And
that,
if
sir.
it is,
Like how do we know if you want to put bicyclobutane or butane bicyclo?
no, always bicycle is prefix.
Okay, sir.
Butane,
Sir, why
bicyclo.
110, sir?
This is 1
Zero.
carbon this side, 1 carbon this side, 0 carbons in the ring. Try to name this
Sir, there are
compound.
2 carbons, no, sir.
All of you try to name this compound.
Yes, sir.
I will clear it. Can you name this compound?
Sir, cannot understand the structures.
What is the name of this? Why you can't understand? I will write once again.
First the shape.
Okay?
Okay, sir.
Okay.
Sir, bicyclo 222 octane.
Perfect. To the bridge head, there are 2 carbons here, 2 carbons here, 2 carbons here. Then obviously it is bicyclo. Okay, sir? Are we clear? So IUPAC names, they can give you common name and ask IUPAC name, or they can say, what is IUPAC name of tetraethyl methane? Tetraethyl methane. Can you name it, sir? Give IUPAC name of it. Hello?
Yes, sir.
What is the IUPAC name of tetraethyl methane? In fact, this tetraethyl methyl looks like this. You can write like that. What is its IUPAC name?
4-ethyl methane. No, sorry. 1-1-1.
3,3-diethyl pentane.
Every IUPAC name has only one capital letter. Okay? There is no gap between ethyl and pentane. So if you practice all the names given in the book, that's enough. Notice the priority order of function groups. COOH has highest priority and alkane has lowest priority. The textbook clearly says the order of priority of function. If you don't know, you cannot answer question like this. You are given a compound like this. Now, what is the hybridized state of first carbon in this compound? What is the hybridized state of first carbon?
sp2.
First I should know what is the first carbon. Is it the first carbon or is it the first carbon? Is it 1 or 1 dash? Which is first carbon?
1.
1.
1, because in priority order carboxylic acid is higher priority than cyanide, right? But if we give same compound with a slight functional group like this, what is the hybridized state of first carbon?
sp.
This is the first carbon. So hybridized state of first carbon is sp. Hybridized state of sixth carbon is sp3. So they can give you like that. Are we clear? Now,
Yes,
the
sir.
first thing is IUPAC names. They can give common names, ask IUPAC name, or they can give you some name, structure, and ask names. Second thing is the priority order you should know. Can you name this compound? Can you name this compound, son? Should I write it again?
Yes.
I am writing again. Name this compound.
Pent3-al 4-onic acid.
Not correct. What is this function group,
Keto
sir?
group will be taken as substituent, sir.
Sir, this is first carbon.
Aldehyde group will be given the most priority, sir.
I would say it is 3-formyne, 4-oxo, pentanoic acid. Can you see the name, sir?
Yes.
Now the question is, how many sp3, sp2, sp carbons it has? How many
sp3,
sp3, sp2, sp carbons it has? This is a model.
all
We
sp3,
can see it is sp2 carbon, it is sp2 carbon, it is sp2 carbon. So out of 6, 3 are sp2, remaining 3 are only sp3. There is no sp carbon in this. You will be knowing the nature of carbons only when you write this structure. Okay, sir? You have to write this structure because of 2 reasons. There is another variety of question. They give me a molecule like this. What is the IUPAC name of this compound? How many sigma and pi bonds it has? Can you identify? Come on, identify the IUPAC name of this compound.
So 2-formyl, 4-oxo,
2-formyl,
2-formyl, 4-oxo.
pentanoic acid.
perfect. Only one
Yes.
student could answer. How many sigma and pi bonds it has, sir?
Sigma 1.
First, you count how many carbons are there. 1, 2, 3, 4, 5, 6 carbons. And how many hydrogens are there? You can see yourself. It has how many hydrogens, sir?
16 sigma.
7 hydrogens,
7.
And how many oxygens?
4.
4,
4.
Now, if you look at this formula, it has total of 17 atoms. In any open chain structure, number of sigma bonds is equal to number of atoms minus 1. So, how many sigma bonds are there, sir? 16. Now, how many pi bonds are there? Always in COH, there is a pi bond. Always in aldehyde, there is a pi bond. And keto also, there is a pi bond. Now, lone pairs. Whenever oxygen is making 2 bonds, it will have 2 lone pairs. Whether you like it or not, the COH also has lone pairs on oxygens. Here you have 4 lone pairs on 2 oxygens. Here you have 1 lone pair. Here you have 2 lone pairs. 2 here, 2 here, 4 here. So there are 8 lone pairs. Okay, sir? Hello?
Yes.
Yes, sir.
So this is the way to look at the questions. A simple last question. In benzene, what is the ratio of hybrid orbitals to pure orbitals involved in bonding? Can you work out this?
All carbons
Okay.
are sp2, right?
All the 6 carbons are sp2. So each sp2 carbon has 3 hybrid orbitals, that is 18 hybrid orbitals. Each sp2 carbon has 1 pure p orbital. So they have 6 pure orbitals.
Yes.
Also in benzene, there are 6 hydrogens.
3:2, sir.
Each hydrogen undergoes sp3. Sorry, each hydrogen uses pure s orbital. Sorry, each hydrogen uses pure s orbital. Now, total number of pure orbitals is 22 and hybrid orbitals are 18. 9:11 is the ratio of hybrid to pure orbitals. Can we see it, sir? Hello? You should have this table, sir. Whenever carbon undergoes sp3 hybridization, it has 4 hybrid orbitals and it has only 0 pure orbitals. If carbon undergoes sp2, it has 3 hybrid orbitals, 1 pure orbital. If it is sp, you understand? Carbon has how many hybrid orbitals depends on the hybridized state. sp3 means all are hybrid. sp2 means 3 are hybrid. sp means 2 2 or higher. Okay, sir?
Yes, sir.
If you know this table, you can answer any question on number of sp3, sp2, sp carbons in a given molecule. Yes, sir? Next. So if I'm looking at the model questions, IUPAC names, sigma, pi bonds and lone pair, I gave an example now. Hello? Sir, take
Yes,
this
sir.
question now.
Yes, sir.
Finally, in acrylonitrile, this compound is called acrylonitrile. Let me tell you. CH2 double one CHO. Acrylonitrile is common name. I am writing again. I think there is some confusion. CH2 double bond CH. What is the IUPAC name of this compound? IUPAC, sigma pi bonds. Ratio of hybrid orbitals to pure orbital ratio. Write down these 3 answers.
Propane 2 in 1 all.
Sir, once you say in, you need not have to say in. It is prop 2 in al. No need to say al number 1. Always aldehyde is number 1. And you need to say that you are a male boy. You need not be introduced as a male boy. If you are male, means you are boy. If you are a boy, means you are male. I think there is no conflict. So this compound is simply propanal. Automatically the double bond is in the second position, and I am sending number of sigma and pi bonds, sir. To know sigma and pi bonds, work out the formula C3H4O. Total number of atoms it has is 8, so sigma bonds are 7 because it is an open chain structure. Pi bonds are obviously 2. Can you see it, sir? Hello? Hello?
Yes, sir.
This molecule is somewhat stabilized by resonance. How can you represent resonance in this acrylonitrile? Let us see.
The lone pair, the oxygen double bond will go to its side.
Let us try to write.
The lone pair.
Wait, I am looking for a place. I can write like this, sir. Oh, sorry. This goes here, it comes here. Okay. Due to this carbon got plus charge. Oxygen. This is the resonance canonical structure. Can you write other resonance canonical structure? Hello?
Yes, sir.
What is the other one? Electrons are flowing in the opposite direction. Then
From oxygen.
this is minus. Notice that the resonance canonical structures have charge separation, which is not there in original molecule. Therefore, original molecule contributes more than the resonance function in this case. Not in all cases, in this case. What isomerism we want to discuss now? we will be discussing isomerism a little bit. Monday class will be totally devoted for isomerism discussion. Okay. Please look at this NCRT as well as the exemplar problems. No other book. Also stay focused on the 30 days crash program I have sent across. Okay. Very good. All of you try to identify answer to this question, sir. How many hyperconjugation structures are possible for this carbocation? I want hyperconjugation, nothing else. You know what is hyperconjugation? Hyperconjugation is an electronic effect. There are electronic effects in organic molecules because of which the carbon chain gets either a positive or a negative charge, because of which the reactivity gets modified. Because of the electronic effects, the acidic strength is increased or decreased. Similarly, basic strength is increased or decreased due to the presence of electronic effects like inductive effect, hyperconjugation, electromeric effect, so on. Yes, sir. It can have only two hyperconjugation forms because hyperconjugation is possible to next carbon positive charge, which is sp3 hybridized. There is one sp3 hybridized carbon with two hydrogens, so it can have two hyperconjugation forms. But this is by and large stabilized by resonance. Notice that resonance is a more stabilizing factor. We continue in the next class Monday, sir. Today, the system is becoming very slow. Or we will wait for a minute. Wait for
So
a
what are
minute.
the exam questions, sir?
Exam portion is only general organic chemistry. You can have 25 questions. You have questions, how many of the following are electrophiles, how many are nucleophiles, or how many functional groups are there in a given molecule, and which is how many structural isomers are there for C4H10O. How many are there, sir? How many structural isomers are there for C4H10O? Can you write? Can you think? C4H10O, for example, this is a formula CnH2n plus 2O that indicates either alcohols or ethers. If the formula is like CnH2nO, it is aldehyde or ketone. Therefore, the C4H10O is looking like CnH2n plus 2O. It is an alkane. It is an alcohol. The alcohol can be like 1-butanol. It can be like 2-butanol. It can be like 2-methyl 2-propanol. It can be like 2-methyl 1-propanol. Can you see the variants? 1-butanol, 2-methyl, 2-butanol, 2-methyl 2-propanol, then 2-methyl 1-propanol. There are 4 alcohols. There are also 3 possible ethers for a compound of formula C4H10O. Total 7, only structural isomers. Look at these questions. Always post your doubts. Your doubt will be answered to in YouTube lecture. You can post your doubt in WhatsApp. Please, you can record your face so that in YouTube I upload your face asking doubt on my explanation. Read this lesson thoroughly. Only 3 sources I want you to use. One is NCRT, the other one is Exemplar. Third one is 30 days crash program in chemistry. The 30 days crash program you will be completing always each day in 3 days time. That's the plan. I'll be sending the book right away and also 3 YouTube lectures on this. Your doubts?
Sir, can you
Tell me.
explain nucleophile and nucleophile, sir?
A nucleophile is one who loves nucleus. A nucleus is somebody who has positive charge. If somebody is loving a positive charge, you are loving a god means you are a male. If somebody is loving a nucleus means somebody has negative charge. If not, at least it has a lone pair that can be donated. So all the molecules which have negative charge are lone pairs which can be donated are nucleophiles. Ammonia is a nucleophile. OH minus, Cl minus, Br minus, I minus, anybody has lone pair. Water itself is a nucleophile because in water oxygen has 2 lone pairs. Anybody who has a negative charge and a lone pair to donate is called a nucleophile. Okay, sir? CH3 minus is a nucleophile. For your information, let me take this. CH3 minus is a nucleophile. If you want to look at CH3 minus, the carbon is sp3 hybridase and it has pyramidal shape. CH3 minus is a nucleophile. H minus is a nucleophile. H2 minus is a nucleophile. Any minus ion is a nucleophile. Or a molecule like ammonia which has a donatable lone pair. Molecule like H2O which has 2 donatable lone pairs. Anybody who has lone pairs, anybody who can bind with a positive center is called a nucleophile. The ability to act as nucleophile is called nucleophilicity. The ability to act as nucleophile. Sir, look at F minus, Cl minus, Br minus, I minus. Which is a better nucleophile? Who can attack positively charged carbon more readily?
I minus.
Is a good entering group, good leaving group, better nucleophile. Okay. So this is your doubt about nucleophile. Further,
Nucleophile.
I just said nucleophile.
Nucleo, sir. EO.
I have already talked to you about nucleophiles. You can have now electrophiles.
Yes, sir.
Electrophiles are those which attack the electron-rich centers. As they are attacking the electron-rich centers, they must carry positive charge or electron deficiency. BCl3, AlCl3. Any electron deficient molecule or any ion that has a positive charge can act like a profile. Look at these basic definitions and remember them. Okay.
Yes, sir.
Now, there can be questions on how many are nucleophiles, how many are electrophiles. C4H10 has how many structural isomers? 7. It has 4 alcohols, 3 ethers. C4H11N has how many structural isomers? C4H11N. That has total 8 structural isomers. We will be continuing our discussion on the same topic on Monday again. But before you go to that, you need to watch the 3 YouTube videos which I share by about 12 o'clock. And also I will share one booklet for you. Crash program.
Okay, sir.
Yes, sir.
I already
Thank you,
shared it in senior intern. For you, I will share in 2-3 hours. Because my system is now fluctuating. Okay. Now I am closing the session. We will be meeting on Monday again. Okay.
Okay, sir. Thank you, sir. Bye, sir.